In this video, we are going to discuss how to calculate the range and time of flight for a horizontally launched projectile. The question says, a stone is thrown horizontally at a speed of 5 meters per second from the top of a cliff that is 78.4 meters high. We need to find how long does it take the stone to reach the bottom of the cliff and how far from the base of the cliff does the stone hit the ground. So if we sketch the problem, you have a cliff and a stone is dropped from this cliff with an initial speed Vx0 of 5 meters per second because it is thrown horizontally. Now, anytime a projectile is launched horizontally, it only has the initial x component of velocity, which we write as Vx0. Here, Vx0 is 5 meters per second. The initial y component is always equal to 0. Then the stone will follow the parabolic path and fall down on the ground. We need to find in the first part how long does it take for the stone to fall from the cliff. Now again we will be using the equation of motion to calculate the total time of flight. We are going to use the equation along the y-axis. We can calculate the distances along y-axis using the equation y equals y0 plus Vy initial t plus half at squared. Now here in a horizontally launched projectile, y0 is the initial height at which the projectile is launched. So for us, that initial height is 78.4 meter, which is the height of the cliff. Y will be the final position. My final position is at the ground here, so y will be equal to 0 meter. Vy0 is equal to 0, whereas a is acceleration due to gravity, which is equal to negative g. Now I'm going to substitute at least the value of the final y position and acceleration to rearrange our term before we solve for t. So we write y equals 0 equals y0. Initial velocity along y-axis is 0, so we can write this term as 0. A we will replace with negative g, so this term becomes minus half g. Small t we will write as capital T to denote as time of flight, the total time of flight. Then we get 0 equals y0 minus half gt squared. Move this half gt squared to the other side. So you get half gt squared equals y0. Now multiply with 2 and divide by g to get t squared equals 2y0 over g. Now take the square root. T will be equal to square root 2y0 over g. This is the expression to calculate the time of flight or the time it takes for the object to fall when it is launched horizontally. Y0 is the initial y position, which is nothing but the maximum height from which the projectile has been released. So I can write this as t equals square root 2h over g. So in any problem where you have a horizontally launched projectile, you can calculate how long it takes for the object to fall on the ground by directly using this rule. And if you don't remember this rule, you can always arrive here by using the equations of motion like how we discussed here. So now let's substitute to find t. T will be equal to square root 2 times 78.4 divided by 9.81. And when you solve this, you get the time of flight t as 3.99 seconds, which you can round off to 4 seconds. In the next part of the question, we need to find how far from the base of the cliff the stone will hit the ground. That means we need to find the range R. So range R is given as the x component of velocity Vx0 times the total time of flight. Vx0 will remain the same throughout the motion. So I will write Vx0 as 5. Time of flight we just calculated as 4. That gives me my range to be 20 meter. So this is how far the stone will fall from the base of the cliff. Let's try another problem. You accidentally throw your car keys horizontally at 8 meters per second from a cliff 64 meter high. How far from the base of the cliff should you look for the key? So I have the initial velocity v0, which is the x component of velocity since it has been launched horizontally. So I have vx0, 8 meters per second. Again, Vy0 will be 0 here because it is a projectile which is launched horizontally. The height of the cliff edge is 64 meters. I need to find how far from the base of the cliff should you look for the key. So I need to find the range R. So if I were to sketch the problem, suppose this is the cliff. You accidentally throw your keys from the top of the cliff. And you need to find how far from the base of the cliff will the key land. We know that we can calculate range for horizontally launched projectile by multiplying the x component of initial velocity with the time t. So if I can find the time t, the total time of flight, I can find the value of range. Total time of flight, as discussed in the previous problem, we can directly calculate by taking t as square root 2h over g, where h is the height of the cliff and g is the acceleration due to gravity. So let us first find what is t. T equals square root 2 times h, which is 64, divided by g, which is 9.81. And when you solve this, you get the time of flight to be equal to 3.6 seconds. Now we will substitute this value in the equation for range. I will calculate my range r as x component of velocity times the time t, which is 8 times 3.6. That gives me the range r as 28.8 meter. So this is how far you must look for your keys from the base of the cliff.